Good day everyone, we are going to talk about AAS or Atomic Absorption Spectrometry and FAES or Flame Absorption Emission Spectroscopy. And we are going to discuss their differences, application, and importance of using those techniques. By the way, my name is Leah Calagoyo from BS Bio of College of Arts and Science in Central Bicol State University of Agriculture. First, let's now go to AAS or Atomic Absorption Spectrometry. Here are the brief overview of this process. First, the solvent is first evaporated, leaving fine divided solid particles. Second, these solid particles move towards the flame, where the gaseous atoms and ions are produced. Third, some ions absorb the energy from the flame and excited to high energy level. Remaining ions will be excited in external sources. Fourth, so the decrease of intensity of the radiation is measured. Fifth, the decrease of intensity of a transmitted light is related to the concentration of unexcited atoms. And that's the brief overview of AAS or Atomic Absorption Spectrometry. Let's now go to FAES, Flame Absorption Emission Spectroscopy. A brief overview of this process are: first, the solvent is first evaporated, leaving fine divided solid particles. Second, this solid moves towards the flame, where the gaseous atoms and ions are produced. Third, the ion absorb the energy from the flame and excited to a higher energy levels. Fourth, when the atoms return to the ground state, radiation of characteristic of elements are emitted. Fifth, the intensity of emitted light is related to the concentration of the elements. Okay, let's now go on how AAS, Atomic Absorption Spectrometry, and FAES, Flame Absorption Emission Spectroscopy, differs from each other. Let's now go first on FAES. FAES, atoms are absorbed the thermal energy and are excited. Their excited atoms return to ground state with the emission of radiation, while in AAS, the atoms which are present unexcited in the ground state absorbs the radiation. FAES, intensity of emitted radiation is measured, while in AAS, intensity of absorbed radiation is measured. In FAES, intensity of emission depends on the number of atoms excited, while in AAS, the intensity of absorption depends on the number of atoms that are unexcited present in the ground state. In FAES, depends on the temperature of the flame, while in AAS, it is independent on the temperature of the flame. In FAES, there is no separation source of radiation is needed, while in AAS, the separation source of radiation is required. In FAES, interference of spectral lines takes place, while in AAS, there is no interference of the spectral lines takes place. In FAES, it is less expensive, while AAS, it is more expensive. Okay, let's now go to the application of both terms. AAS, or Atomic Absorption Spectrometry, is primarily used for determination of trace metals in many types of sample composed of organic or inorganic matrices. It has been utilized in the study of forensic scientists for many years. Using this technology, forensic scientists can perform in-depth analysis of blood samples, brain, muscle tissues, and gunshot powder residue. While in FAES, it is a very useful technique for identifying elements such as sodium, barium, calcium, and lithium, and has been employed by researchers for the elemental analysis of trace metals in a variety of samples. Let's now go to the importance of both terms. In AAS, it is an easy, high-throughput technology used primarily to analyze elements in a solution. As such, AAS is used in food and beverage, water, and clinical research, and also for the pharmaceutical analysis. While in FAES, it is a qualitative test used in chemistry to help determine the identity or possible identity of metal or metalloid ion found in ionic compound. And that's all for today's video. I hope you learned something about the two types of spectroscopy, the AAS or Atomic Absorption Spectrometry, and FAES, the Flame Absorption Emission Spectroscopy. Thank you for watching and goodbye.